So we're pleased to have Marco Arcell, the CEO of Acwa Power, speaking to OGN Energy Magazine. Hello, Marco. Marco, when it comes to meeting the water needs of the region, how safe are we?
I think we're very safe. We have great off-takers like SWPC here, DIWA in Dubai. All the companies that we're working with, the off-takers are planning the system very reliable, sturdy, and that is, I think, the most important thing. Then each one of us who operate in the system are doing our best to build a safe, reliable, for the long-term plans.
Okay. So, and do you think that the desalination is a process that can continue forever, considering that we have a never-ending seawater? I mean, we see a lot of seawater, but how far can we go with desalination, considering that it's a very energy-intensive process?
Yeah. So let me first start by the energy-intensive comment. We, over the last 10, 15 years, reduced the energy intensity to produce 1 cubic meter of water by more than 80%. Right. So it followed the same trajectory as renewables, and we don't think it will stop here. So in terms of energy intensity, I wouldn't be too worried. In terms of the other big thing that is mentioned for desalination is the brine that then you discharge into the water. Well, yes, there is some brine, but in reality, the increase in the salination that you do in the water is very marginal, almost impossible to measure, and that's actually these models of dispersion of the water in the sea when you discharge it back. So I think that the potential is very big, continues to be very big, because at the end it's a tiny fraction of the total seawater, and not just in the region. I was just in Italy, so I'm back after signing agreements for desalination there also. And we see an increase in demand in Europe, in the Americas, everywhere. People are looking at desalination really as one of the key technologies to ensure reliable, safe availability of water.
Okay. We see Acwa Power to be a leader now, and it is growing in its leadership.
Yes.
Is Acwa Power going through acquisitions or is growing through projects?
Yeah. Today we are the largest private desalinator in the world with 7.6 million cubic meter per day of desalination capacity. That's equivalent to the need of about 20 million people here in the region of the Gulf. So it's already quite massive. We grew through organic development, so building one plant at a time, and we will continue to do that. We are starting to look beyond the region. So first North Africa, China, Indonesia, Azerbaijan, we're looking at other regions, but we're starting also to consider potentially Latin America, Europe, other places, because at the end, water desalination is handled everywhere in the same way that we're used to, through an IPP model where you get a tariff and you can then supply these in the most economic way.
Okay. When it comes to the sizes of plants, be it anything, this region is known for its huge size. Yes. Like we have the Tawila plant,
yes.
and that's supposed to be a very large desal plant. Are we looking at anything bigger than that as well?
Yeah. So far we have built the largest water plant, water desalination plant. And then we build the largest water desalination plant, and then we build the largest water desalination plant, and then we build it again. So 4 times in a row, every time we pass our own record, we beat our own record. So I think that potentially there is the chance that in this region we will build something bigger in the future. I think that then every country is different. So if I look at opportunities that we're following up in Morocco, in Egypt, in Indonesia, in China, they're much smaller than what we see here. One is that typically what you have to see is whether you do a lot of desalination and then you pipe it away, or you do it for the local need.
Okay.
It's always a balance, and every country will address it differently.
Okay. So when it comes to sizes, efficiency is an issue. So my question would be, are too many smaller plants better, or is it just one big plant?
So if you can make a bigger plant, of course, you have efficiencies, and then, of course, the cost, the energy consumption is lower, so you should try to do that. Okay. But as I mentioned, it's not the only thing that you take into consideration.
Okay, and again about efficiency, how is efficiency measured at water desal plants?
The main parameter that we use is the specific consumption, so how many kilowatt hour of energy you need to produce 1 cubic meter of desalinated water. Just to give you an idea, we went from more than 10, 15 years ago to less than 3 today. We're today at 2.7.
Okay, great. Emissions, again, is an issue with every plant. Scope 1 and 2, how are you coping that emissions? Maybe a little about Scope 3 as well.
Yeah. Well, those are, I would use maybe more our power portfolio to give you an idea of that.
Okay.
Until probably, 6, 7 years ago, all our portfolio was fossil fuel. Today, 46% of the portfolio is renewable energy. That's Scope 1, so what you do.
What you do, yeah.
Scope 2 is basically how you use the energy that you use, and I think that the example I gave you about the specific consumption in our water is the best example, and the reduction has been immense, has been in the range of 80%, 85%.
Okay, so Scope 3 is one thing that companies really struggle with.
Yeah.
I know they said that it's maybe not our responsibility, but then again, we have to look into it. Is anything done?
So we're just starting to assess that. I come from previous experience as a utility. As a utility, you have many more ways to influence Scope 3. Scope 3.
Yeah.
If you are not touching the customer, at the end we're finishing our responsibility at the border at the plant, and then there is a utility or an off-taker who's managing the general public. So that becomes a little more difficult because we are not influencing how much the final customer is paying.
Yes.
So are they maybe wasting energy or wasting resources because the cost is too low? Or are you supplying them in an efficient way, or what do they do with it? It's very difficult for us to manage that as much as a utility, but we're starting to assess that to see if there's anything that we can do.
Okay, environmental impacts. I know you said that brine is something that maybe, as people would want to know, what are the other, let's say, waste that comes out of water desal plants, and how is that treated, and how does Acwa Power do that?
Yeah, I would say that probably the only other major element that we monitor for, let me say, not so much emission, but interaction with the environment is the use of chemicals that, of course, you need to dose basically to ensure that you don't have scaling of the water, that if you have any algae or whatever, it doesn't get into the potable water, and then the characteristics of the potable water. What we are doing is leveraging a lot of digitization, artificial intelligence, so that we can monitor in real time the characteristics of the water that we treat, and then monitor in real time the characteristics of the water that goes out of the plant, so that basically you can reduce as much as possible the use of any chemicals that you need to use in the treatment.
Okay. Now, again, we're going to come back to the huge costs of desal plants. There are some costs associated with that, and there are some people who are, like, say, environment-friendly people. They would have those concerns. How do you allay the concerns of such people and you as Acwa Power, the producer, what would you tell them that you?
Yeah, I think the first one is really, it's become really, really efficient to produce desalinated water, and that's the first thing. The second is really that everything is done with a very limited impact on the environment. So everything that we do is really under control by all the national regulation, national codes that one has to follow. So that is totally under control.
Okay. You're growing as far as your green hydrogen portfolio is concerned, and NEOM seems to be your largest.
Yes.
What do you say about that?
Yes. So we are the first mover in green hydrogen. Together with our partners, Air Products and NEOM, we're building actually the largest plant for green hydrogen, actually green ammonia. So the hydrogen is transformed into ammonia that today is easier to ship
to transport,
for export in the world. It's a plant that produces about 1.2 million tons of green ammonia per year. It's a quantity that is difficult to conceive. So I will tell you how much the investment is. It's an $8.5 billion investment. Until today, we have spent about $1 billion. So we're well underway. If you go to the site, you start basically seeing the various parts of the plant that is coming up from the ground. It will be completed by the end of 2026. It will be the first in the world. Today is the only one in the world. Not only that, we're also breaking ground on the second plant in a few weeks in Uzbekistan.
Okay.
That is basically a smaller plant that is the phase one that will be sold locally to a local petrochemical and fertilizer company. and then after that we will scale it up potentially for exports into Europe. But we're developing many more, from Morocco to Indonesia, from Azerbaijan to China, so in 10 countries overall, because we think that we're called by all these countries, by the way. We have two big advantages. So one technical, we have done it, and we have been able to optimize it. To give you an idea about NEOM, 4,000 megawatt of power generation, 400 gigawatt hour of battery storage, 2,000 megawatt of electrolyzer. So the combination, why not 5,000 of renewables? Why not 1,000 of battery storage? Why not 3,000? So all that optimization is the technical optimization to ensure that the cost is the lowest. The second is contractual, and it's the fact that we closed the project financing with 23 banks who gave us $6.4 billion of non-recourse financing. That means purely on the merit of the project. So these two, a contractual skill and a technical skill, makes it that if we participate in a project elsewhere, we probably accelerate the development by at least a couple of years.
Okay, cool. So green hydrogen, this is going to be exported to around the world?
To the world, yes. I think in the short term, we believe in this green ammonia that will go mainly to fertilizers. The second is SAF, so sustainable aviation fuel. And the third, particularly in the Far East, in Japan, is co-combustion on coal plant to basically lower the intensity of the CO2 emissions.
Okay, it was a pleasure speaking to Marco. Thank you so much.
Thank you. Thanks a lot.
Thank you.